All right, and now the task of sketching your own slope field, which are free response style questions. And you're going to be provided with an equation for the derivative, which is the slope. So you want to keep that in mind. And then you're also going to be given a selection of points. Any points that are bolded, you are expected to make a small portion of the tangent line at those locations. If you look down at Model 2, there's far less points that are bolded. In fact, there's only 8 points that are really emphasized down there. So we shall begin. So I started you off with a very simple derivative formula. So this is saying that the slope of the tangent line is equal to the x value, right? So if you think about it, for instance, at all of these points where x equals 1, that's what the slope is going to look like as well, okay? So at x equals 1, dy over dx will equal 1. So, to the best of your ability, you're going to draw a small line segment, that of a tangent line, that appears that the slope is 1. So for instance here, a slope of 1 would be up 1 over 1, up 1 over 1. So, essentially if you continue this tangent line, it would connect this point with this point. So you want to try to draw that the best of your ability. Same thing here. If you imagine this tangent line having a slope of 1, it would eventually connect with this point and this point. So you're just really trying to eye it out and drawing, again, a tangent line that would connect this point with this point. And really all of these should look parallel to each other because they do have the same slope. And that's how you would want to kind of eye it out down here as well. Right. So for instance, at x equals 0, right, at x equals 0, all of the derivatives, the slopes of the tangent lines will also be 0. Which is a horizontal line, right? So at all of these guys, it's easy. We're just going to draw a horizontal line segment. At x equals -1, the slope of your tangent line will also be -1. So I'm going to start over here. Okay, again, left 1, up 1, it would really have to connect to that point. So to the best of your ability, again, these should all look parallel. And at x equals 2, our slope of our tangent line is 2. So these get a little trickier. So for instance, I'm going to start over here. And if I did draw a tangent line, it would have to connect with this point, right? This point and this point would have a slope of 2. So, and then when I draw these, I'm just basing it off of that first one. And how they grade these is, yes, it has to kind of look accurate, but they also grade it in relatively speaking. In other words, your slope of 2 definitely needs to look steeper than your slope of 1. And at x equals 3, our slopes of our tangent lines will also be 3. So it gets really steep here. And, therefore it gets a little tougher to draw so accurately. But like I said, when they grade it, they look for how the slopes are related to each other. So these are steeper than this, these are steeper than that, and that's how we wanted to draw them, right? These had a slope of 1, these had a slope of 2, these had a slope of 3. So it can get a little tricky, but don't get so caught up in you know, would it perfectly connect with the proper dot? You know, you're really essentially just estimating. Based on your slope field above, what shape would the particular solution to this differential equation be? So again, the solution to the differential equation is the shape that the slope field makes. And this is very similar to the first one that I showed you, in that it definitely looks like it takes the shape of a parabola. And if you consider yourself finding the actual antiderivative of x, you would get an equation that models a parabola. You would get 1/2 x squared plus c. You know, so that's not a coincidence. This is algebraically the interpretation of what this slope field is supposed to represent.